another really interesting comment. So as you can see, this was only 17 hours ago. And he was just wondering whether, because I compared the Poisson model with a machine learning system, so a decision tree. So then he was thinking, well, could you do a similar thing except for over and unders? Since, only recently I was asked, someone suggested looking at the Poisson model for the over and unders, since I've always been thinking about the result. Well, anyway, so that began a rapid series of exchanges. And, it's all up there, you can see it. And basically, I was saying that I'd love to do that, but I don't have the odds data. I mean, I knew from footballdata.co.uk I could get the data about the Premier League and other leagues, and that's where I'd get the odds. And then I could, apply machine learning to it. But I mean, if I don't have the odds for overs and unders, I can't do the same thing. But basically, Zafir, if that's how it's pronounced, pointed out that actually no, that data is there. He suggested blah blah blah. I've looked for data on betting odds. But football data provides the betting odds. So I actually had that file. I just hadn't noticed that it had that information. So if you go to footballdata.co.uk, it has the notes explaining what the various things are. I just thought it had odds from many bookies. I didn't know that it had overs and unders and all kinds of things actually. So I'll have a look at this more later. So if you have the data, if you know what the odds were for the different games, well then it's just a matter of a couple of lines of code to produce the decision tree in R. And here we are. I just loaded up the data, added an extra feature, overs, telling it, whether the game ended up being 3 or more goals. And then, that's just the way I did the fitting. And it produced this. Now, it doesn't have the odds at different bookies, but it does have the average odds. So this BB average is the average odds from something like 30, nearly 40 bookies. And in a way, I mean, actually, that is, if I had one number, that is the number that I'd want. I mean, that's more, that tends to be better. And here's the magic formula. So then next, but then I was complaining, the comments are there, I was kind of going, oh, it doesn't have the odds from a bookie. That was last night. But then when I woke up, I went, what are you saying? If you could have one thing, you would want the average. You don't want the odds from one bookie. So this is good to go. But does it work? So I just had a look. These are all the Premier League games that have been played. It might not be updated to the last few, but so this is Premier League game number 338, etc. This is the average odds that we're going to have more than 2 goals, and over tells us whether we did have more than 2 goals. So from this we can kind of see that, okay, this was here the odds were 1.67, so everyone thought we were going to get many goals, and we did. Here we thought we'd have more than 2 goals, but we didn't. In these two, again, they were odds-on favourite to have 3 or more goals, but we didn't have that. So, it's not that simple. What I did next was I just used predict. So here's the model, and then you can just say, using this algorithm, this method, predict. What would you have predicted? I mean, if I told you that the odds were 2, what would you predict? And it would predict that we were going to have more than 2 goals. So from our predictions, we can make a list of what this would have said. And I've just done 1 means true, 0 means false. So this is the code for what actually happened, and this is the sequence for what this algorithm would have predicted. So, if you would have known that you would have known that the odds were 2.0 before the match started. So you would have been able to predict. And then you can compare what the predictions were with what actually happened. And I might be wrong here, because again, I should have. I mean, I just did this morning. I should have created an extra column so that you have what the odds were, what actually happened, and what the predictions were, so that we could read it straight off the table. But I didn't, because I literally just created this a couple of minutes ago. It got 6 of the outcomes right, and it got 4 of them wrong. So there might be something there. I fit the model to the entire data set. So when looking at these 10 games, the model was created knowing what the answers were. So really, if it had fit the data perfectly, it had already been shown what happened in these 10 games. So, I mean, if I'd used say a random forest or something with thousands of trees, it would have, I could massively overfit it and get it right all the time. The nice thing about this kind of decision tree is that we can see it clearly isn't overfitting. I mean, even though we're talking about matches that it was shown the result to, it tries to find a pattern. So anyway, that's just the latest update. I just wanted to put this up so Zafir could see it actually, and we'll see how it goes. As you can see, I mean, if you have any thoughts or questions, much appreciated. We can keep progressing with our analysis. I'm also looking at some cricket IPL stuff. You might have noticed I'm posting something there. Just because IPL is also massive. I mean, it's a huge betting market. But there aren't that. I mean, there aren't that many methods to tackle that. I know about the Poisson model. I know about different ways that you can analyze football, which is the biggest one. But it's more Wild West, I think, in the cricket, which makes it interesting. I mean, if you can spot a pattern, a way to analyze cricket, that could be incredibly lucrative. I mean, if you look at Betfair on a typical IPL match, you'll have like 20, 30, 40 million bet on it. Again, a lot of it could be hedged, but which is a side thing. But basically, it's a very big market, and it's a very interesting problem because, as I said, it's a Wild West. If you can come up with anything, there might be fantastic opportunities there.